Hey, what's up everyone? My name is William, and today we're going to be going over the modulation effects that are included in Logic. So first of all, I've opened up a new session here, and I've made a track for each effect, as well as a track without any effects on it. As you can see, there is quite a few tracks in this session. So there's going to be, quite a few effects that we're going to be covering in this video, so it might be a little long, just letting you know. Starting off, before we jump in, I'm using Carla Lyric 02. I got that by just going to Apple Loops, searching for vocals, and then I scrolled all the way down to see Carla Lyric 02. It's right here if you want to use the same lyric that I'm using. So jumping right into it, let's just first listen to what this sounds like without any effects on it.
Get up, get up, get up, get up, get up, get up. Oh.
Okay, so that's what our vocal sounds like. We're going to move on to the first effect, which is the chorus effect. I just went over to Modulation, clicked on chorus. I already have it on the track, so I'm just going to open it up. This is the factory default settings for this. And now what a chorus effect is it delays this, or it creates a copy essentially of the signal and delays it and modulates it using an LFO. And the settings we have here control the LFO parameters that are modulating our delayed version of our signal. So we have this rate knob that controls just the rate of our LFO, the intensity, how intense our LFO is. Higher values mean it is more intense than lower values. And we also have a simple mix knob that determines whether we're listening to the affected signal or the dry signal. 0% is we're listening to the dry signal. 100% is we're listening to the complete wet signal. So that's something to keep in mind as well. I'm just going to make sure we're listening to the factory default and we can just hear what it's doing to our vocal.
Get up, get up, get up, get up, get up, get up. Oh. Get up, get up, get up, get up, get up, get up. Oh. Get up, get up, get up, get up, get up, get up. Oh.
So obviously as you go more intense, especially with rate and intensity, it doesn't even sound like the vocal. You're just hearing the LFO modulating it essentially. That's about it for the chorus effect, though. Not too much to it. It's a fairly simple effect to grasp and understand. Next, we'll be moving on to the ensemble effect. The ensemble effect is similar to the chorus effect in the fact that the ensemble effect is actually just multiple chorus effects. You can have up to 8 chorus effects working here, and we get 3 different LFOs controlling it rather than just one. So going over some of the parameters, we get 3 LFOs right here. We can control them in this view, and we get a visual representation of each LFO in this area here. We can turn them on and off by just simply clicking the power buttons next to the name. 2 of them are standard LFOs, and then the last one is a random LFO, which just adds more complex modulation to your ensemble effect. We have simple rate, which determines how fast or how slow the LFO is going, and then we also have intensity, which determines how intense our LFOs are. That's about it for the LFOs. They're all the same, again, except the random. It has more complex, waves due to the fact to just add more unique modulation to your sound. Going to the bottom, we have a voices knob. This determines the amount of affected voices. So right now we have essentially three chorus voices happening here, where you can have all the way up to 8. You know, 1 to 8. Obviously, it shows us a visual representation on the LFOs as we decrease and increase the value. It shows us the slightly delayed voices. I'm going to leave it at 3 for right now. Next, we have our stereo spread. It just determines the spread of our affected signal. We can have 100%, which is just the entire stereo. 200%, it artificially spreads it more. And then 0% obviously is a mono signal. So I'm going to leave that at 100 because we just want a default stereo spread for this. Next, we have this phase knob, which determines the phase relationship between the individual voices in the ensemble. This depends on what type or how many voices you have. That's why it's a percentage value rather than a lot of phase knobs will actually be a value rather than percentage. But that's why that is percentage, because it depends on the amount of voices we have. So it's relative, you know, dependent on whether we have 1 voice or 8 voices. Next, we have volume compensation, which this is just if we want to boost or you know, turn down our affected signal. This is just for the actual effect, not for the dry signal. We can do that, you know, if it's a little quieter, we can bump it up, we can give it some volume compensation. And then lastly, of course, we have our output mix signal. Right now it's at 30%. Again, you know, 0% is a completely dry signal, 100% is a completely wet signal. Anything between, you know, obviously mixes the two together. So let's just listen to what this sounds like with our vocal sample. I'm going to turn it off first, and then we're going to listen to it with it.
Get up, get up, get up, get up, get up, get up. Oh.
So that's what it sounded like without the ensemble effect. Now with.
Get up, get up, get up, get up, get up, get up. Oh.
So obviously you could hear the differences there. Definitely play with some of the presets maybe.
Get up, get up, get up, get up, get up, get up.
You know, adjust some of the LFOs. Experiment a little bit to find out what you like about this effect. Definitely a very cool effect. Moving on to the next effect, which is the flanger. So the flanger effect is actually very similar to the chorus effect. The only difference is the delay time is actually significantly shorter when it comes to the flanger. So we have a lot of the same parameters. We have this rate knob, which controls the rate of our LFO. We also can change it to sync to our BPM if we wanted to, or leave it at hertz. Then we also have intensity, determines how much modulation is happening with our LFO. And then we have this knob that we haven't seen before called feedback. It determines how much of the input or how much of the output, excuse me, is being routed back into the input. This can get different tonal changes, and it can also get some like sweeping like effects. Sometimes even metallic-y sounding things start happening. So this is definitely fun to mess with this knob here. And then, of course, last we have our mix knob, like usual, which determines how much of the affected signal we're hearing. So let's listen to our Carla Lyric 02 with out this this flanger on it, and then we'll listen to it with the flanger on it.
Get up, get up, get up, get up, get up, get up. Oh.
So that was without the flanger. Now with the flanger.
Get up, get up, get up, get up, get up, get up. Oh. Get up, get up, get up, get up, get up, get up.
So you can see, as you know, you start adjusting with rate and feedback alone, you get some very interesting results. But that's about it for the flanger. Again, nothing too complex here. Very similar to the chorus effect, just different sounds you get from it since the delay time is such or much significantly shorter. You know, it's much shorter than the chorus delay time. Next, we're going to be moving on to the microphaser. What the microphaser does is it actually creates a swishing phasing effect with your audio signal. And we have, you know, not too difficult of parameters here. We have a rate knob that controls our LFO. Again, we can sync it to our BPM or not. And then we have an intensity knob, which determines how much modulation is occurring. And then we also have feedback, which again is determining how much of the output is being routed back into the input, which it determines, you know, how much of that swishing sound we can hear. You know, obviously a higher value will be able to hear that much better. So let's just listen to, again, the vocal sample without any effects, and then let's listen to it with the microphaser.
Get up, get up, get up, get up, get up, get up. Oh.
So that was without any effects. Now with the microphaser.
Get up, get up, get up, get up. Get up, get up. Oh.
So you can hear some of the phasing that's happening there. It's a pretty cool effect. Not too much to that one. Next, we're going to be moving on to the modulation delay. So the modulation delay effect actually uses the same principles as the flanger and chorus effect. However, we actually get to control the delay time when we're using the modulation delay, and that's what really makes this different. We have a lot more flexibility with this. You can get combinations between flanger and chorus effects that you can't in the other two effects alone. So going through the parameters, first we have our feedback slider. This determines how much feedback's happening. If we go into the negative values, it just inverses the phasing of our feedback signal. Next we have the flanger dash chorus knob here. What this does is it sets our delay time. If it's all the way on the left, it's a flanger effect. If we're in the center, it is a chorus effect, and if we're all the way on the right, it's just a longer delay that's much more noticeable. So that's something to keep in mind. I'll put it at 50% for now, leave it at a chorus effect. Next we have these two buttons down here. We have dewarble, which this just makes sure that the pitch stays constant in our sound, whereas this constant modulation button ensures that we have a constant modulation width in our sound, no matter the rate that we're modulating at. Next is the modulation intensity slider. This slider determines how much modulation is occurring. This is something we've seen before in some of the other preset or some of the other audio effects. So pretty straightforward there. Moving on, we have two LFOs in this. We have LFO 1 and 2. This is our mixer for our LFOs. You can determine, if we want both LFOs, if we just want LFO 1 or if we just want LFO 2. We can do that there. Next, we have our actual rates for our LFOs. LFO 1 is on the top. We actually can control our left and right channels for both LFO 1 and LFO 2. This button right here determines whether or not these left and right channels will be synced or not. So if it's synced, it'll sync the LFO. Like LFO 1 will be synced on both the left and right channels as well as LFO 2. If this button is not clicked, we can have them not synced if we wanted that. So that's just something to keep in mind for the different effects. Also, when they are synced, we have control of our LFO phasing here, and this is just a basic phasing that controls the amount of phasing that's happening between the two channels, or related to the two channels. At 180 is what that was set at, so I'll just leave that there. Next, we have the volume modulation slider, which this just determines how much of the modulation is affecting the volume of our sound. If you want the volume to be modulated, you'd affect that here. And then lastly, we of course have our output mix, which we've seen plenty of times already. So I won't even go in depth with that. So let's just listen to what our Carla lyric vocal sample sounds like without our modulation delay.
Get up, get up, get up, get up, get up, get up. Oh.
Now with our modulation delay.
Get up, get up, get up, get up, get up, get up. Oh. Get up, get up, get up, get up, get up, get up. Oh.
So you can get quite a few different effects. You can even use it as a kind of resonator since you have control over the delay time and whatnot.
Get up, get up, get up, get up.
So that's very cool. You can do some very cool things with this modulation delay. A lot of flexibility there. Moving on, we are going to be covering the phaser effect. So what's happening with this phaser effect is, it's taking a copy of the original signal and putting it slightly out of phase. And because that's happening, the original signal and the slightly out of phase version, have slight timing differences when it reaches, their respective highest and lowest amplitudes. And the LFOs are modulating that timing difference, and that's what this phaser effect is doing. So starting off with some of these parameters, obviously you can see it's broken down into 4 sections here. We're going to start over with the sweep section. We have this stages knob. This just changes the algorithm that's happening for the type of phasing that's occurring. Next we have the sweep mode. We can change that between squared and exponential. That's just what type of sweep mode we're having. Next we have this ceiling and floor slider, which we can drag these individually. This just determines what frequency range we're going to be modulating with our LFOs. Moving on to our actual LFO section, we have, of course, 2 LFOs here. We can adjust the rates individually. We can also sync the rates to the BPM if we please. And we also have a mix slider between the 2 LFOs down here underneath them. Next to that, we also have a phase knob, which determines the phasing of the 2 channels, the 2 LFO channels, so we can determine whether or not there's going to be phasing there. Next, we get the feedback section, and we have just a simple feedback knob that determines how much feedback we want to occur, as well as we can turn on and off this filter right here and determine whether or not we want to cut any highs or any lows out of the signal. Lastly, about the feedback section, we have this warmth button. It adds slight warm, distortion to our sound. That's what that does. And next we have, of course, our output slider. This one's slightly different than some of the ones we've seen before. We get 0 to 100, which is just like any other mixed signal, whether 0 being dry, 100 being wet. However, we also get negative values, and these negative values are it's essentially the same thing as the positive values. However, the signal is going to be inverted. It's going to be in the inverse of it. So that's just something to keep in mind. You can get some different sounds if you inverse it or if you don't. That's about it for the phaser effect. So again, let's take a listen to what it sounds like without the phaser and then with.
Get up, get up, get up, get up, get up, get up. Oh.
So that was without the phaser. Now with.
Get up, get up, get up, get up, get up, get up. Oh.
So you can hear some of the phasing that's happening there. And there's quite a few presets. I clicked on one right before that last phrase. I clicked phase filter 02. So there's quite a few different presets. Definitely check some of those out. But that about wraps up the phaser effect. Next, we will be moving on to the ring shifter effect. So the ring shifter, in my opinion, is one of those effects that looks more complicated than it actually is. Opening up, it's a little intimidating, especially compared to some of the other modulation effects that we've already covered. But the ring shifter is just a frequency shifter and a ring mod in one effect. So we have a quick rundown of the sections of this effect. We have mode buttons up here. We have an oscillator right here. We have a delay that we can put on our signal. We have output parameters right here. And then we have a modulation section at the bottom. So what's happening here is right now we're on frequency shifter dual mode. And we can switch between frequency shifter and ring mod clicking the related buttons to them. Ring mod has oscillator and sidechain, which the ring mod effect is just the modulation of the amplitude, and the modulation is either coming from the oscillator right here, or it's coming from the sidechain, which we would have to input a signal to get that that sidechain signal. Whereas the frequency shifter, it shifts the frequency of the signal, but it's not the same as pitch shifting because it changes the harmonics of the sound. Single is just a single frequency shifted signal, meaning that only one signal is being shifted. So it determines whether or not, the oscillator here determines whether or not it's a higher pitch or a lower pitch, depending on whether we're in the positive or negative values. Whereas this dual band is oscillating both of these stereo channels separately. So, if we are using this this oscillator to determine our frequency, one band will be a higher pitched frequency when another band will be the lower pitched frequency. So you get some interesting effects. The easiest way I can show you the difference between that is just really quick, just because I know that sounds confusing, explaining it. But frequency shifting with the single mode sounds like this, whereas with the dual mode, let's try that again. Single, dual. It sounds like, the single sounds more just high pitched. The dual, you can kind of hear the back and forth. It's more noticeable at higher signals just because it's more extreme. So definitely mess with that when you're working with the ring shifter. I tend to like dual mode when it comes to the frequency shifter mode of the ring shifter. Anyways, moving on, next we have this oscillator here, which I've already been messing with this. This determines the frequency of the oscillator, how fast it's oscillating. And then we also have these buttons down here that determine the type of mode that it's in. Linear mode, LIN button right here, means it's an even balance between the whole spectrum, whereas this exponential mode, it's much smaller value changes near the zero, whereas when you get up higher, it becomes more extreme value changes. So that just depends if you want, precise changes around zero, and then you want to have extreme changes around the higher frequencies. Exponential would be for you. If you just want something that's even throughout, then linear would be the choice there. Next we have the envelope, follow, and LFO modulation sliders. This just determines how much of the signal is being modulated by these parameters, and we can control these parameters down here. Obviously, we have the envelope follower. This is just a envelope follower modulation. This determines the sensitivity, how much is modulation, how much how intense we can hear the modulation happening, and then this determines how fast the attack and decay is. And we can of course turn that on and off with the power button. Again, we also have an LFO for modulation. We can control that with the power button, turning it on and off. Then we also just get some LFO controls to change the shape of it, as well as the rate and the sync button to change whether or not the rate is syncing to the BPM. But these two parameters we can use to modulate the oscillator up here by changing these values, or we can even use it to modulate the output dry wet right here. Next we have a delay that we can put on our signal. We can sync it, or we can just have it freely be a certain amount of time after, and then we can also set the level of that delay right there. Next we have feedback knobs and stereo width knobs. Feedback is just determines how much of the signal, of the output signal, is being routed back into the input, which can change the harmonics of the sound in general, whereas the stereo width determines how wide our stereo image is for our sound. And last but not least, of course, we have our dry wet knob here, which determines how much of the affected signal we're hearing and how much of the dry signal we're hearing. 0 is dry, 1.0 is 100% wet. So that's just something to keep in mind. There's quite a few presets for this. Definitely, mess with those. Let's listen to a couple of different effects with this ring shifter on our vocal sample. So you can see there's a lot of cool sounds you can get from the ring shifter effect. Definitely check that out, mess with that, especially mess with some of the modulation, because I didn't cover that too much in this tutorial. And again, if you have any questions about any of this stuff, definitely make sure to ask your mentor about it and have them go over it. But the next effect we're going to be covering is the rotor cabinet effect. The rotor cabinet effect actually emulates what our sound would sound like playing out of a rotating loudspeaker cabinet. Just to show you what I mean by that, I'm going to click the rear position, and you can actually see it's spinning this thing inside, and it's actually playing the sound out of this virtual cabinet here, and we have our virtual mics listening to it. So with this effect, we can control multiple things. We can control our mic processing. So at the top, we can control our horn, which is the top mics, how far or close they are to that to the horns. This drum mic down here, depending on the position of the drum mic, we can change this knob. And then also we have a balance between the signals we're getting. Of course, we can change whether or not we're listening to the front or the rear of this cabinet, and as well as we can put whether or not there are deflectors on this cabinet if we're listening to the rear. And these are just things that are on the horns of the cabinet. It's kind of hard to tell, but there's this little piece that's being put on the horns when I click it on. It just changes the sound slightly. That's personal preference, up to you. The next parameters we get are the motor parameters. We can determine how fast acceleration and the max rate of our motor here, as well as we get a normal control or a motor control, and these are just different motors that we can use for our cabinet here. And one of the last few things to go over is there's actually this control over here, which it changes the speed of the motor. We have a slow, a brake, and a fast speed. As you can see, it's going very fast now. I put it in the center, it's, whoops. If I put it in the center, it stops. If I put it on the left, it's a slow speed. So that's just something to keep in mind. The last thing is there is different types of cabinets that we can change. When we're on this real cabinet mode, we actually have more control. We can actually change out these mics and things. But when we're on any of these other cabinets, we actually don't have as much control. We only can have the mics in the front. It actually doesn't show us a visual representation either for some reason. We can still, choose whether or not we want the deflectors on. But all we get is the distance of the mics and the angle of the mics. And we get that balance knob again. We don't get the positioning of each of the separate mics and things like that. But we still get all the same motor controls. So that's just something to keep in mind. This is a interesting effect in my opinion. You can make some different sounds that you wouldn't normally hear. So let's just listen to what our vocal sample sounds like without this and then with this rotor cabinet effect.
Get up, get up, get up, get up, get up, get up. Oh.
Now with our rotor cabinet effect, it sounds like this.
Get up, get up, get up, get up, get up, get up. Oh.
It's a very interesting effect that you can add to your audio sample or to your MIDI clip. So that's about it though for the rotor cabinet. Definitely one of the more interesting effects in my opinion. Definitely check out some of the presets for that to go over that some more. But the next effect we're going to be going over is the scanner vibrato. There's not actually too much to the scanner vibrato effect. It actually is just emulating the scanner vibrato section of a Hammond organ. And we have, vibrato and chorus types that we can choose from. Each of these representing, each C value representing a chorus, each V value representing a different vibrato. They're just different intensities. C0 is actually just nothing, whereas, the rest of the values are a different type of effect. No, you can't change the depth of the vibratos. You can only change the depth of the chorus effects. And we also have, over here the stereo phase knob of these. And when it's set to free, this just means that we get control over the left and right rate individually, like independently. If we have it synced to a certain phase, then it'll be a synced stereo phase dependent on what we set here. And then of course we just have control over the modulation rate with these knobs. Again, we only control the left one if we're syncing the stereo phase. If we're freely changing the stereo phase, we have control over the left and right knobs. I'm just going to recall it to factory default. We're going to listen to what the vocal sample sounds like without the scanner vibrato and then with.
Get up, get up, get up, get up, get up, get up. Oh.
That was without the scanner vibrato. Now with the scanner vibrato.
Get up, get up, get up, get up, get up, get up. Oh.
So some cool effects that we can do with that. Moving on to the spreader audio effect. The stereo spreader effect actually just simply spreads the stereo spectrum of our audio signal. And it does that using an LFO. We can control the rate of that LFO right here with this knob. We can control how intense that modulation is with this knob right here. We also have a channel delay in samples. And samples are the smallest unit possible in a DAW. And this is, to add to the perceived wide width, I should say, of the signal. And then we also have our dry wet mix knob here that determines how much of the affected signal that we are hearing. This is a pretty straightforward effect. You would only use it in certain scenarios. Like I probably wouldn't use it in this scenario. But I'm going to use the stereo spread preset so we can hear the difference. So let's listen to it without the spreader on.
Get up, get up, get up, get up, get up, get up. Oh.
Now with the stereo spread preset on the spreader, let's see what that sounds like.
Get up, get up, get up, get up, get up, get up. Oh.
Okay, so not much to that effect. Moving on to our last modulation effect, the tremolo effect. The tremolo effect actually modulates the amplitude of our signal using LFOs. So, just looking at this, we have a simple rate knob, first of all, that controls how fast our LFO is going to be, modulating the amplitude. Then we have our depth, which determines how much, how intense the LFO is modulating our signal. 100% is more intense, 0% is not modulating at all. We can see this on the right hand side. Of course, this is our visual representation. And we also have the smoothing and symmetry right here. You can also, instead of clicking this percentage and dragging up, you can also click the points on the waveform. We have these two options to change the wave shape of our LFO. Last but not least, we also have, offset, so we can offset our wave by a certain amount of degrees. We can offset it by negative 180 degrees all the way to a range of positive 180 degrees. We can drag these tall points to do that, or we can just click and drag on the offset text over here. The very last option we have is our phasing of our second wave, since we do have separate channels for our left and right for our stereo image. So we can set the phase to be different for this if we wanted to offset our phasing, for our left and right channels. I'm gonna just go to the factory default though, so we can hear what this tremolo is actually doing to our sound. First, let me turn this off so we can hear what it sounds like without the tremolo.
Get up, get up, get up, get up, get up, get up. Oh.
Now what it sounds like with the tremolo.
Get up, get up, get up, get up, get up, get up. Oh.
You could hear it going back and forth between the left and right speaker because these are offset. So as the left channel is increasing in amplitude, the right is decreasing, and vice versa. As the right is increasing in amplitude, the left is decreasing. So it gives us that back and forth kind of motion. But that is the very last modulation effect. I hope you learned something in this video. That was a lot to cover, I understand. We covered all the modulation effects. If you have any questions about anything, be sure to contact the Recording Connection, talk to your mentor, ask them about it if you have questions. I hope you learned something this lesson though. Again, my name is William. Thank you for watching.